7.5 Properties of trapezoids and kites. Essential question: what are the properties of trapezoids and kites? Take a minute to draw on your notes a trapezoid. Notice that it has to have exactly one pair of parallel sides. If it has two pairs, we're going to call it a parallelogram, not a trapezoid. We have parts like base angles, we have legs, and when the legs are congruent, we call that an isosceles trapezoid. We want to show that this is a trapezoid, which means we need to show that we have some parallel sides. So I'm going to use the slope formula to find some slopes. I'm going to find the slope of RS, and I can see from the picture that it's rise 1 over 2. So this is going to be 1/2. And the slope of OT is rise 2 over 4. So this is 2 over 4, which is 1/2. Now these slopes are equal, so this tells me that these are parallel because the slopes are equal. Now I'm going to find the distance of this leg, which is 3, and I'm going to find the distance of this leg using the distance formula, and that's √8. Notice they're not the same, so this is going to not be an isosceles trapezoid, but it is a trapezoid. So ORST is a trapezoid. Your turn. Go ahead and stop the screencast and see what you can do. And here's the answer. Let's take a look at 3 things that we can learn about isosceles trapezoid. These two are converses of each other. So if you have an isosceles trapezoid, the base angles are congruent, and if you have base angles congruent, then you have an isosceles trapezoid. Now this is already an if and only if statement, which says that if you have an isosceles trapezoid, the diagonals are congruent. The diagonals are congruent. Now that happened with a rectangle, but unfortunately these diagonals are going to bisect each other like they did in the parallelogram. Let's go ahead and try to find the angles for this isosceles trapezoid. Now remember, the base angles are congruent, so that means this angle will be 85 degrees. Now these are parallel lines, so these two consecutive angles will be supplementary, which means this is going to be 95 degrees, and again this will be 95 degrees because these are base angles. All right, your turn. And here are the answers. Mid-segment. We had a mid-segment for a triangle. We also have a mid-segment for a trapezoid. It's the segment that connects the midpoints for the legs. Now this trapezoid does not have to be isosceles. It's just any ordinary trapezoid. Now here's a theorem that says that the mid-segment is equal to 1/2 the sum of the bases. So I'm going to write this in words. Mid-segment is equal to 1/2 base 1 plus base 2. They're asking me to find the length of the mid-segment, so I wrote down the formula, and one base is 12, the other base is 28. That's going to add up to 40. Half of 40 is 20, so that's how long the mid-segment will be. We want to find the length of the mid-segment. Now instead of using the formula, what I'm going to do is I'm going to find the midpoint, which I've done here and here, and then I'm just going to find the distance between the two midpoints. So this is going to be 7 take away 4 squared plus 2 take away 8 squared, and that's going to be 9 plus 36, which is √45. So this length is √45, which is about 6.7. All right, we're going to skip this one and go on. Properties of kites. A kite is a quadrilateral that has 2 pairs of consecutive congruent sides. So here's a picture: 2 consecutive congruent sides, 2 consecutive congruent sides, 2 pairs. Now these 2 are consecutive, but they're not congruent. Some very interesting things about diagonals and angles in a kite. One, the diagonals are perpendicular, and the other is that there's 2 pairs of angles in a kite that are congruent. Only, did I say 2 pair? I meant 1 pair. So there's exactly 2 angles that are going to be congruent. Now here's the theorem that shows that the diagonals are perpendicular, and it comes from the converse of the perpendicular bisector theorem. So this point right here is equidistant to C and A, and point D is also equidistant to C and A. So B and D are both equidistant, and when they're equidistant, that means they lie on the perpendicular bisector. So this is acting as a perpendicular bisector for CA, and that's how we know that diagonals of a kite are perpendicular. Let's take a look at this kite and see if we can find angle D and angle F. Actually, angle D and angle F will be the same because in the kite, two of the angles are congruent. So we know x plus 115 plus 73 have to equal 360. Because it's a quadrilateral, they have to add up to that. So 316 take away 115, we're going to have 2x is equal to 245. Now we're going to divide by 2, and each of these angles will be 122.5 degrees. In a kite, we have these measurements, and we want to find the value of x. Now we know that all four of these angles have to add up to 360, like we did a few minutes ago. So 3x is equal to 75, x is equal to 25. What are the measures of the angles that are congruent? And it's the two 75-degree angles. Okay, here in a nutshell is everything we've covered in this unit. Parallelograms, rectangle, rhombus, and even down here is that square right here. What is the most specific name for this quadrilateral? And the most specific name is that it's a parallelogram. I notice the diagonals bisect each other, then it's a parallelogram. I don't see anything else. I can't say it's a square because I know it's not a rectangle. If it were a rectangle, the diagonals would be congruent. I can't say it's a rhombus because I know nothing about whether the diagonals are perpendicular. So this is the best we can do. All right, your turn. See if you can give this most specific name for each quadrilateral. Okay, and the answer here should be kite, and that's because two consecutive sides are congruent. And right here, this would be a trapezoid, but not an isosceles trapezoid because this length of this diagonal is not the same as this. This one is just a quad. Nothing special about it other than it's a quad.